Okay, so number 35 says, in the triangle shown, if theta increases at a constant rate of 3 radians per minute. Okay, so there is a related rate here. It's saying d theta dt, because this is a related rate problem. Okay, it's going to increase, so it's a positive 3 radians per minute. At what rate is x increasing in units per minute when x is equal to 3? So we're trying to see, again, it's increasing, so it's going to be a positive, but we want to see what is dx dt equal. And we're going to say in units per minute. And we want to see when, and the point of time is x is equal to 3. So looking at what my pieces are, I should look at a trigonometric function and identify my angle, and then opposite over hypotenuse, which in this case is going to be from SOHCAHTOA, is going to be opposite hypotenuse, it's going to be sine. So the sine is the function that you're identifying. Okay, so if we're looking at it as dreads, the diagram's already shown, the related rates we've already identified what we need to find and what we're given. E is the equation that we're going to have, so that's what we've identified here. So it's going to be sine of theta is equal to x over 5. Now we're going to take the derivative and then substitute. So I need to ask myself, as I have my equation, am I given or do I need d theta dt? Well, I am given it, so I'm going to use it and I'm going to leave it as a variable. Then I'm going to look at x. Am I given or do I need to find dx dt? Yes, so I'm going to also leave it as the variable of what you see. Now remember, I'm taking in respect to time. This is a related rate problem. So it's d everything dt. So looking at sine of theta, it's going to be cosine of theta d theta dt. Now looking at this is the same as 1/5 times x. So if I look at this, I'm just going to say it's 1/5 dx dt, because the derivative of this guy is 1/5, but then x is not 1. The derivative of x is x prime or dx dt, which is in this case what we're trying to look for. So it's going to be 1/5 dx dt. Okay, so I need to find what are all the pieces that I have. So I'm given this, and I need to look for dx dt, but I need to ask myself, am I given theta? So I'm not really given theta, but I'm given enough pieces to find theta. So sine of theta is equal to 3 over 5. So if I said what is theta, well, I take the arc sine of both sides. That would cancel, so that I just have theta. And it's going to be the arc sine of 3/5. Remember, I need to be in radians mode always in my calculator, in calculus. Okay, those of you in physics, make sure you've always changed it back to radians from degrees. So this is going to go right here. So what I'm looking for is the cosine of this value is going to be multiplied with d theta dt. Okay, so let's find this real quick. I'm going to go to the arc sine. So it's going to be, yes, let's check real quick that my mode is radians. Okay, so I'm going to go arc sine, and it's going to be the 3 over 5. Okay, so arc sine of 3/5 is this following. Okay, so I'm going to do now, I'm going to cosine that value. Okay, because this was theta, I'm going to cosine that value. Okay, so cosine the answer, remember exactly, round at the very end, gives me 0.8. So 0.8 times this d theta dt of a positive 3 is equal to 1/5 dx dt. So all I need to do is multiply it by 3 and then multiply both sides by 5, because I'm trying to get rid of this fraction here. So 0.8 times 3 times 5, and that's dx dt. So 0.8 times 3 times 5, and I get 12 as my answer. So the answer is E.